So here you see a big block of mass 10 m, and then you see a block of mass m which is placed on top of this block of 10 m mass, and the length of this base of this bigger mass is 2.2 meter, and all the surface is like this, and the ground all are frictionless, so there is no friction. And now we want to release this system from the rest. So initially all the system is in rest, and we want to calculate when the system is left from the rest how much distance the smaller mass will travel. So as we understand this, as we leave this from the rest position, we will see that smaller mass m will start sliding on bigger mass 10 m along this direction because of no friction. But as this moves down, this will move in forward direction. So now let's see, we want to see how much this mass has traveled along the x axis. Maybe we can define this as x axis. And now what we will start with is something like, say, x is position, and position of, say, some object particle A with respect to B is defined as position of A with respect to ground plus position of ground with respect to B. This is, you have to keep in mind all the time. Now if you just do like this, A, the position of A with respect to ground, minus, it will be just reverse, which is position of B with respect to ground. This is to keep it in terms of ground. Now say A is, in our case, is smaller small body of mass m, and B is, say, bigger mass 10 m. So m is moving with respect to 10 m. If it will move down till here, it will go in the negative direction, 2.2 meter. So it will go minus 2.2. So what we will do is, so position of, you can write as like this, m with respect to 10 m is equal to position of m with respect to ground minus position of 10 m with respect to ground. So position of m with respect to 10 m after it has moved down will be negative of 2.2 meter, because it is moving left, and positive x direction is along this direction. So along the x direction it will be moving minus 2.2 meter. Now we want to calculate this value, so we will keep it as like this, and say this 10 m with respect to ground has moved forward with certain distance, say x. So x of m with respect to ground will be x minus 2.2. So this will be the position of a smaller mass m with respect to ground. If x has moved in the forward direction by x, that is 10 m has moved forward with the x distance in the positive x direction. Now since this complete system along x direction, we don't have any net force along x direction is 0. Along y direction we have many forces, which is gravitational force, but along the x direction, if we keep system as m and 2m as a complete system, and then we see this as a whole system, we will see that there is no force along the y direction, along the x direction. So we can say that since initially force is 0, we can say acceleration of center of mass of the complete system is 0, Since initial velocity of the whole system is 0, we can say initial velocity is also 0. Now we want to calculate the velocity of center of mass, or you can say the position of center of mass with respect to say with respect to ground is Vx is equal to ut plus half at square, where u and a is the acceleration and initial velocity of center of mass with respect to ground. Since both are 0, a and u, so this is also 0 at any instant of time t. So position of center of mass will remain at 0. Now we know that center of mass of any system is calculated by this formula m1 x1 plus m2 x2 divided by m1 plus m2, where m1 is m and m2 is the 10m, and x1 is the position of m with respect to ground, and x2 is position of 10m with respect to ground. Since our center of mass is 0, we can say m1 x1 plus m2 x2 is equal to 0, and then we put the value of m1, which is m, we put the value of m with respect to ground, which is x minus 2.2, and then we put the value of m2, which is 10m, and then we put the value of x2, which is say x in the forward direction, so this is equal to 0. And now if you calculate this the value of x, this will become equal to 0.2 meter, and that's all. So here we have used some of the concept which is like relative position, and which is which you have to keep in mind all the time. This is also valid for velocity and acceleration as well. So position of a with respect to b is always given by position of a with respect to ground plus position of g plus b, and if you just make it positive to negative, it will be position of b with respect to ground. And from here we have calculated position of m with respect to ground. And also we have used the concept that initial velocity and acceleration of the center of mass of a whole system is 0, so and net force is also 0, so center of mass is remaining the fixed, only the components, that is m and 10m will move in either direction. So if you use the concept of center of mass and you calculate this center of mass position, you see it is 0, and then you calculate this like this. So in the next video I will talk about more about other problems.